Hello everyone, welcome you all to this video lecture. So in this class we are going to discuss about the steam power plant, right? So actually how does a steam power plant work? What is the main function of any steam power plant, right? Okay. So before going to understand the concepts of steam power plant, let us revise something whatever we have learned in basic thermodynamics, right? So in basic thermodynamics we discussed two laws, right? Basically already we have discussed three laws. Out of this, more important one which is necessary for this lecture, that is your first law and the second law, right? So already we have discussed the first law of thermodynamics, and already also we have discussed the second law of thermodynamics, right? So let us revise before starting our lecture of the steam power plant. Okay, so first law, it is associated with the conservation law of energy, right? So when we are talking about the first law of thermodynamics, it is actually the conservation law of thermodynamics, right? So when we are applying the conservation law of thermodynamics to any closed system, right, we can see two conditions, right? The closed system may go under a cyclic process or a single process, right? So it will be considering the first case where closed system is undergoing a cyclic process, right? So in this case, according to first law of thermodynamics, we know the net energy interaction in terms of heat, that is Q net, that will be equal to net energy interactions in terms of, right? So this is the outcome from the first law of thermodynamics when it is being applied to a cyclic process for a closed system. Done. Okay. So if this closed system it is undergoing through a process, right? So if the closed system it is undergoing a process, that means process simply means the change of the condition of the system from one state point to another state point, right? So if I'm saying this is one system and initially it was containing some gases, right? Okay, and if there is some gases, then we can say it will be having some pressure, temperature and volume like this. So this is the initial condition, and if we'll be doing some interactions, then due to this particular interaction this state point 1 will be changed to state point 2. That simply means we are doing a process, right? So in this case what we did or derived, that is net heat interaction during this process, that will be equal to change in internal energy for this particular process or for this particular state change, that plus your net work interaction, right? So this is the first law of thermodynamics for a closed system undergoing a process. Okay, so for closed system we got these two relations from the first law of thermodynamics, right? Again, if we'll be trying to apply this particular first law to an open system, in that case we saw the steady flow energy equation, right? So steady flow, that means we are assuming certain assumptions over here. We are assuming that the flow is happening. So you know, as this is an open system, that simply means some mass will be entering to the system and some mass will be leaving to the system. So if I'm considering this is my system, that simply means in this case some mass will be going into the system and some mass will be leaving this particular system, right? So steady simply means the property change at any section, okay, with respect to time, that will be no change, right? So there will be no change of any property at any section with respect to time, so that is the steady condition, right? So if I'm saying this is the passage or this is the section where I'm considering or checking all these properties, like this is statement 1 and here I'm checking all other properties. So this is the inlet section and this is the outlet section, right? So at this point, at any time, whatever properties I'm calculating or watching, so all these properties will remain same. So that is the condition of your steady flow. Okay, so let me tell it again. So steady flow simply means the properties at any section with respect to time, it doesn't change. Right? So properties do not change with respect to time at any section. Okay, so in this particular condition, whatever energy equations we got, that is the steady flow energy equation, right? So that we can write like this: H1 plus V1 square by 2 plus GZ1. Okay, so here M dot. Okay, so if I'm saying this is the mass flow rate at inlet section, plus here this is Q, that will be equal to M dot 2 H here 2 plus V1 square by 2 plus GZ2 plus W dot. Okay, so here if I'm saying that the change in the properties, it is remaining same at any section. Okay, and if I'm saying this is the control volume or an open system. Okay, so in that case, according to the conservation of mass, that means what the conservation of mass is saying, that the inlet of mass, okay, the amount of mass which is entering to the system, that amount of mass will be going out of the system. That simply means there is no accumulation of mass inside any system. Okay, so there is no accumulation of mass. Okay, so in that case I can write m dot 1 will be equal to m dot 2. Okay, so I may replace this is as m dot. Okay, so this is the general equation I can say. So by imposing some sort of more assumptions, we can write this steady flow energy equations for other devices, right? Okay, so already we have discussed all these things in the first chapter of your basic thermodynamics, right? Okay, so today we'll be trying to see the steam power plant. Okay, and basically steam power plant is a cyclic device, right? So in that case we can say this law will be applicable, right? Okay, and for a cyclic device there is another law also, right? So this is the first law which is telling about the qualitative, sorry, quantitative law. That means how much amount of energy is going to the system, or how much energy is interacted through the system or for the system, right? By the boundary, for the boundary we can say. Okay, so first law is saying about the quantity. This much amount of heat is interacted, this much amount of work is interacted, right? Okay, so but in the second law, what it is saying, this is saying about the quality of energy, right? Okay, so what is the degradation of energy? Already we have discussed all these things in the second law of thermodynamics, right? Okay, so it is showing the direction of energy transfer, in which direction energy can be transferred, right? Okay, so there were two statements. One was your Kelvin Planck statement, another one is your Clausius statement. Okay, so as we are going to discuss about the steam power plant, which is a device which will be producing some work, right? So what is the function of steam power plant? Again, we will be discussing about that. Okay, basically steam power plant, it is a device or which will be producing some work output, right? So we'll be using the Kelvin Planck statement, right? So in case of your Kelvin Planck statement, it is talking about any device which will be producing some work as output, by taking heat as input. Okay, and if we be talking about the Clausius statement, it is talking about the transfer of heat from a lower temperature region to higher temperature region, right? So by applying the Clausius statement, we have already discussed about the refrigeration system, right? Similarly, by applying this Kelvin Planck statement, we'll be trying to learn how steam power plant. Okay, so let us try to understand this Kelvin and Planck statement in detail. Okay, so let us move to next slide. Okay, so this is the steam power plant we are going to discuss. Okay, so before that, let us try to understand what is the second law of law of thermodynamics and what is the Clausius statement. Okay, sorry, Kelvin Planck statement. Okay, okay. So this is the Kelvin Planck statement, and this is a possible engine according to Kelvin Planck statement. Right. So this is the, okay. Let me write it down. Okay, so what was the Kelvin Planck statement? He said that it is impossible to create such a device which will be producing work interacting only with a single reservoir, right? So I'm not discussing in detail. Still, you can have this particular statement. It is saying that it is impossible to create such a device which will be producing work interacting only with a single reservoir, right? That simply means if we are doing interaction only with a single reservoir, okay, then it is impossible for us to produce work. Okay, so it may be possible if we are interacting more than one reservoir, right? So if we are interacting in terms of heat or in terms of work, and we are trying to produce some work from any device, then we must interact more than one reservoir. Okay, so that's it is the Kelvin Planck statement. Okay, so this, if I'm saying this is the source which is maintained at a higher temperature, that is TH. So in this case, TH, it is greater than TL, right? Okay, where TL is what? It is the temperature of sink. Okay, so TL, it is less than the TH value. Okay, so TH, it is greater than the TL. Okay, so what is source? Again, if we'll be trying to revise, source is that reservoir can give the amount of heat. Okay, so we can extract much many amount of heat, whatever we want to extract. Okay, so it will be, there will be no effect on its temperature. Okay, so the reservoir which can give many heat, so that is known as the source. Okay, so we can extract as much as we want, right? So there will be no change in temperature. Okay, obviously this is your hypothetical case where we are trying to extract heat, but there is no change in temperature. Okay, similarly, what is sink? So this is a reservoir where we can add the amount of heat, how much, however we want. So there will be no change in temperature. So this is the uh, reservoir where we can add heat, and this is the reservoir where from we can extract heat. Okay, okay, so now, so if I'm saying I am preparing an engine or any device which will be producing work, so in that case I must use two reservoirs. So one will be source where from I'll be getting the heat, and one will be sink, so to which I'll be rejecting some amount of heat. Okay, that simply means if I want to extract W amount of work from QH amount of heat, then I can never convert this total amount of heat into work. Okay, so there must be some amount of rejection of heat or rejection of heat, right? I hope it is understandable, right? Okay, so by understanding this concept, already we know, or the concept of your IC engine, right? So already we know there are two types of engine basically. So the work producing devices are known as the engine. Okay, so the devices which will be producing work, those are known as engine. Okay, so engine may be classified as two types. One is your external combustion engine, and another one is your internal combustion engine. Okay, so external combustion simply means your combustions will be happening outside the engine. Okay, so where will be producing work, at that place there will be no combustion. Okay, so if I am producing work from here, then combustion will be not happening in this particular region. Okay, so it may be happening somewhere out of this particular device. Okay, and if we be talking about internal combustion engine, so combustion will be there inside the engine itself. That simply means inside this particular device where we'll be getting work as output, in that particular device itself, combustion will be happening. Okay, so I hope this is clear. Okay, so now let us try to understand some more thing, right? So now here we are trying to understand the concept of steam power plant. Okay, so we will be trying to understand what is steam power plant. Okay, so before going to understand the steam power plant, we should know what a power plant means, right? So power plant, so these are the devices, or these are the engines we can say, okay, which will be producing power. Okay, and definitely the motive of these stations, power stations, to produce the electrical power, right? Okay, so these are basically there to produce the electricity. Okay, and by taking the energy from the steam, we, if we are producing electricity, then such a device or such a station is known as the steam power plant. Okay, I hope now you are in a position to answer this particular question, what is steam power plant. Okay, so power plant, that simply means it will be producing electricity. And steam power plant, that means if it is taking energy from the steam and it is converting into the electrical power, then it can be known as the steam power plant. Done. Okay, so how we will be producing the electricity from steam? So now let us try to understand that. Okay, okay. So in case of your any engine, here we are saying that this particular engine, it will be producing work as output, right? So suppose I am assuming we are getting work, so we are getting mechanical work as output. Okay, and if we have got mechanical work, and now if I am feeding this particular work to any generator, right? So I am having with the mechanical work. So mechanical work simply means in terms of motion. Okay, so we are getting some work in terms of motion. That means I am getting some rotating shaft with me, right? So I have got a shaft where it is rotating. Right? Now, if I am connecting this shaft to a generator, okay, so this generator will be producing electricity, right? So I hope it is understandable till now, right? So what I'm saying, so suppose I am having a device with me, right? So this device, what it is doing, so it is simply converting or producing some amount of work, right? So let us say that this is the device and this is producing this amount of work, right? So which type of work is it? So this is the mechanical work. Okay, and mechanical work simply means it is in the form of any motion. So suppose I am saying this is the shaft and now it is rotating. Okay, so this shaft is rotating, and this, if this rotating shaft is connected with a generator, so what is the function of generator? So generator will be converting this mechanical energy into electrical energy. I hope it is clear. Okay, so we will be feeding this mechanical work to a generator. So this generator will be producing electricity right now. Okay, so now our intention is to convert the energy which is with steam right now, that to the mechanical energy. Okay, so we are not interested how we will be converting this mechanical energy to electrical energy. So that can be done inside a generator. Okay, so now what we want, we want to convert the energy which is with steam to mechanical work. So what are the forms of energy with steam, that we'll be trying to understand. Okay, now then we'll be trying to understand how we can convert that energy which is inside steam to the work. Which type of work? Again, mechanical work. And mechanical work simply means in the form of any motion, rotation we want over here. Okay, so I hope what is our intention, it is clear to all of you. Okay, so if we be trying to summarize what we have discussed till now, so we have discussed that what is steam power plant. Okay, so steam power plant simply means we are trying to convert the energy which is inside the steam into electricity. Okay, so there are two steps, right? So some form of energy which is with steam, and that form of energy by any means we are converting into mechanical energy. And after getting the mechanical energy, we'll be trying to convert this mechanical energy to electrical energy by the help of a generator. Okay, so now if I'm having with the this particular mechanical energy, then electrical energy we can get, right? So now most important thing for us, how we can convert this steam energy, okay, the energy which is with steam right now, to mechanical energy. Before that, again, we should know what type of energy the steam may contain. Done. I hope it is clear. Okay. Okay, so let us move further. Okay. Okay, so here it will be saying, so if we are having any engine, okay, that means any power producing device, then we should take heat from any source and we should reject some heat to any sink. Then only I can get some amount of work as output. So this is the necessary condition. So I must take heat from any source and I must reject some amount of energy to any sink. Then only I can get some amount of work as output. Okay, so and I have already told you that there are two types of engine. One is a external combustion engine, another one is the internal combustion engine. Okay, so the steam power plant, it is coming under this particular category, which is external combustion engine. So now we are not interested in this particular condition. Now we are interested in this particular condition where combustion will be taking place outside that particular device, where mechanical work will be produced. Again I am repeating, combustion will be happening outside of that particular device where mechanical work will be produced. Done. Okay, so if we'll be saying, so suppose I am saying there is one device and there is another device and there is another device. Okay, so in this particular device what it is doing, it is producing this amount of work. Okay, and in this device I am saying this is amount of heat we are providing, and I am saying this is the device where I am rejecting this amount of q or this amount of heat. Okay, so I can see I'm requiring three devices over here. Okay, so definitely this is a cyclic process or mm, cyclic device you can say, right? So ultimately all these three will be coming under one device, right? So the aim of this particular, all these devices are what? To produce work, right? So I am saying that in case of your external combustion engine, so combustion will be happening somewhere out of that particular device where work will be produced. Okay, now I am saying from here we are getting some amount of work. Okay, that is why I am saying, so let there is another separate device. Okay, let this is the device and from this I am getting some amount of work as well. Okay, so again to get some amount of work as the output, I'll be requiring heat as the input. So let I'm saying this is a device where I'll be adding some amount of heat. Okay, so again what I need to do, I need to extract or reject some amount of heat to get this particular work. So let I'm saying there is another device where from I'll be rejecting some amount of heat to the surrounding. Okay, or this is the sink. Okay, and this sink in our case is your surrounding. Okay, that means we'll be rejecting heat to the surrounding. Done. So from here suppose I'm getting rejecting equal amount of heat. Okay, so these three important components must be there to produce some amount of work from heat. Okay, so again where from I'll be getting this particular heat, that we'll discuss. To whom will be rejecting heat, that we'll discuss. How this will be rejected, that will be discussed. How we will be getting this particular work, that will be discussed. Okay, so after rejecting this amount of heat, so how there will be a link between all these three. Okay, is there any other device, that also we'll discuss. Okay, so is it clear up to now? Okay, so let me revise again what I have told you. So I told that if I want to produce some amount of work, then I should give some amount of heat to this particular device and some amount of heat must be rejected from this particular device. Okay, and in case of your external combustion engine I am saying that there will be this work interaction and this heat interaction will be done separately. That means combustion will be done separately from that particular device where we are getting the work as output. Okay, so combustion cannot be happen at that particular device where we will be getting work. Okay, so if I'm getting work from any device which is present over here, then I cannot add heat to it. Okay, in this case I cannot add heat. Okay, so that is why I'm saying there is another device where I can add heat. Okay, similarly, let there is another device where from we can reject heat. Okay, so that we have to show how this all these devices are linked, right? Okay, and is there any other devices which is required during this cyclic process? Okay, and how this cycle is being operated? Okay, so let us try to understand that. Okay, so there are basically this heat addition is done inside the boiler. Okay, so there is a device whose name is boiler. At this particular device will be adding heat to the system. Okay, or whatever will be going through it, right? So inside the boiler what will be happening, normally your water will be flowing, right? So here water will be flowing and will be adding heat to this particular boiler. Okay, and after addition of heat what will happen, this water which is present in this particular device, this will be trying to evaporate, right? So first of all the temperature of water will be trying to increase. After getting the boiling point temperature of this particular water, so it will be trying to evaporate. So after that, again if you will be adding the heat, then it will be converted, or it will be converting into vapor, right? Again after that formation of all this liquid water to vapor, again it will be adding heat, the temperature of vapor will increase, so we'll be getting the superheated vapor. Okay, so this device where we are about to add heat, what is the name of that particular device? So that device is what? This is boiler. Okay, so in boiler we are going to add heat, right? So we'll be adding some amount of heat at this boiler. Okay, so what is the inlet to the boiler? So at the inlet we'll be having liquid water. Okay, so we'll be having liquid water at the inlet of the boiler, and what may go out of the boiler may be saturated vapor. Okay, maybe super heated vapor, maybe mixture. Okay, so mixture of vapor. Okay, according to the amount of heat added. So if we have added maximum amount of heat, in that case we'll be getting superheated vapor. Okay, so if we added less amount of heat, then we'll be getting a mixture. Okay, so similarly, okay, so we may get these three conditions, right? So already we have discussed in when we were discussing the your what pure substances, right? So definitely it will be adding heat to any liquid, so in this case water. So what it will be happening, first of all the sensible heat will be added. As a result of that, the temperature of liquid will increase. Okay, and after addition of sensible heat, that means when the liquid water will be reaching at its boiling point temperature, again if you will be adding heat, then your liquid water will be converting into vapor, right? Again after complete formation of vapor, if you will be adding heat, then this the temperature of vapor will be increasing. That means in this case also we are adding the sensible heat. Okay, so now this vapor will be converting into superheated vapor. Okay, so these are the device. Okay, so this is the device in which will be producing the steam. That means if I'm saying this is the device over here. Okay, so let us try to draw it. Okay, sorry, it is not visible, right? Okay, so now if we'll be trying to draw a device. Okay, and this is the device, and where what we are doing, we are adding liquid water. Okay, so suppose I am getting superheated steam. Okay, so the name of this particular device is what? This is boiler. Okay, so here we are providing liquid water and we are getting superheated vapor. Okay, now so after getting this particular superheated vapor, now I want to expand it through a device where it will be producing power, right? So now I want to expand it. So let there is a device somewhat like this. So let me draw it. Okay, so now in this case, so we are getting your superheated vapor from here, right? And now I am supplying this superheated vapor to this particular device, okay? And from this particular device, we'll be getting something, right? So what is the name of this particular device? Okay, so this is your turbine, okay? And in this case, we can say, in this case, we can say this is steam turbine, okay? So what is the function of turbine? Okay, so what is the function of turbine? That is, it will be producing the mechanical work. Right? So here I have already told you that here will be some device which will be producing work. Okay, so how it will be producing work? Basically, there will be a shaft somewhat like this, right? So there will be a shaft, and over this shaft, some blades will be mounted, right? So over this shaft, there will be number of blades that will be mounted. Okay, and when will be passing our superheated steam with a high energy with it. Okay, so what are the forms of energy we'll discuss. So we can say that the superheated vapor, it is having maximum amount of energy because we have added the heat over here, right? So as we have added, the energy content of this particular vapor is maximum, so it has been increased, right? So this superheated vapor, which is containing maximum energy with it, now we are supplying it through a device, okay? And definitely before sending it to this particular device, suppose I am increasing the velocity of this particular vapor, okay? And due to this increase in velocity, I can say the kinetic energy of the superheated vapor, that will be increased, right? We know this particular relation, right? Kinetic energy, that will be equal to mv square by 2. So if I'm saying I have increased the velocity of the superheated vapor, then in that case the kinetic energy must be increased. Done. Okay, so I am sending the superheated vapor with a high kinetic energy to this particular device, whose name is steam turbine, right? And with this particular high velocity, if our steam will be flowing through this particular device, then obviously our fan blade, which are there, they will be trying to rotate. And if fan blades will be rotating, then obviously with this shaft which is mounted over here, this will also try to rotate. And that is what we are wishing for. Okay, that is what we are looking for. Okay, we want that this shaft must rotate, and if this shaft will be rotating, then we have got the mechanical power, mechanical, and ultimately I'll be connecting this shaft with a generator, and this generator will be producing electricity. Done. Okay, now, so which steam which has come to this particular device, that is steam turbine. Now, sorry, now after giving this amount of energy, this work, okay, after getting expanded through this particular device, now the energy will be decreasing, right? So after getting after producing this amount of work, now it will be moving out of this particular device and it will be going out, right? So if I'm saying there were the superheated vapor, then when it will be leaving, so it has lost the energy which was having with it, right? Now that means we can say here the steam which will be moving out, so it will be having less energy than this particular steam, right? Suppose I am saying this is the state point 1 and this is the state point 2. That simply means the energy which was over here, that will be high as compared to this one. Okay, now if we will be trying to find out the work interaction, that means here this amount of work we have produced, before that this amount of energy was there with this particular vapor. So when it has gone out of this particular device, now it is having with this amount of energy. So the amount of energy lost by this particular steam, that will be equal to the amount of work we have produced, right? So although it is now not necessary for us to calculate how much amount of work we are producing for this particular steam turbine, still you can have an idea, right? Suppose I know that how much amount of energy was there with steam. Okay. Now again, if I know the amount of energy which is there with steam when it is moving out of this particular turbine, then obviously we are able to find out the amount of work which our steam turbine is producing. I hope it is clear. Okay. So now the steam which is having the less energy with it is moving out of this particular steam turbine. Okay. So what is our work? So we have added heat and we have got work. Now it is our duty to reject some amount of heat. Okay. So now this steam will be sent through a device. Okay, which will be rejecting heat to the surrounding. We can say, right. So now here there is a device. Okay. So what is the name of that particular device? What is the function of that particular device? Okay. So what is the function? Okay. Tell. I hope you are in a position to answer this particular device. Okay. So what is the function of this particular device? So this device will be extracting some amount of heat from this particular steam, right? So now here steam is going to this particular device. So when I am sending steam to this particular device, then this device will be extracting some amount of heat from this particular device and it will be sending out, right? So what is the function of this particular device? So it will be rejecting some amount of heat from the steam to out to the ambient, to the surrounding. Okay. So name of this particular device is the condenser. Sorry. So name of this particular device is what? This is condenser. So let me write it down. Okay. So now what I'm saying here at the inlet of the steam, it has lost lost the energy. The steam is having the less energy with it. Now if I'm sending through any device which will be extracting heat from this particular steam, then this steam which was previously in the form of vapor, then it will be taking heat from this particular steam, then obviously it will be trying to condense, it will be trying to convert into liquid first, right? Before decreasing its temperature, first of all it will be trying to convert into liquid, right? That means in this case the vapor is entering to the condenser and at the exit we will be getting the liquid. I hope it is clear, right? So there is a boiler. So let us try to revise whatever we have discussed till now. So previously there is a boiler. Okay. So what in case of a boiler, we are providing liquid water to the boiler and we are adding heat. Okay. And after addition of heat, this liquid water it is getting converted into superheated vapor. Okay. So this superheated vapor now it is sent to a device where we want to produce work. Okay. So in that case I am saying that we are increasing the velocity of this particular. Okay. So how can we increase the velocity? So we may use a nozzle over here. Okay. So although that is not important, but you can remember that there will be a nozzle. Okay. The superheated vapor will be sent to the turbine by the help or the through a nozzle. Okay. So in between boiler and turbine we may be having with a nozzle. Okay. So what is the function of nozzle? It is used to increase the velocity of fluid, right? So here we are increasing the velocity of the fluid and we are sending the high velocity fluid, high kinetic energy fluid to a turbine. Okay. Steam turbine. Okay. So due to high kinetic energy, these fan blades which are mounted over this particular shaft, they will be starting the rotation. And due to rotation of these blades, this shaft will also rotate. And when this shaft will rotate, we have got the mechanical power. Okay. Now this mechanical work which we have got from this particular shaft, that is fed to a generator, and this generator will be producing electricity. Okay, so we are not interested right now how this generator is getting converted, or how this generator is converting the mechanical energy into electrical energy. So now we are not interested in that particular part. Okay, okay. So we have produced this work. After producing work, definitely the steam which was sent into this steam turbine, that has lost some amount of energy. Okay, so after reduction of that energy, now what is the role? We have to reject some amount of energy from the system. And what is the system? What is the working fluid we are taking over here? That is water, right? So from the working fluid, we have to reject some amount of heat to the ambient. Okay, so now we'll be sending this particular pot, this particular steam to the condenser, where it will be getting condensed. That simply means it will be changing its form from the vapor to the liquid. Okay, now definitely here you can say, here we are having the liquid and here also we are having the liquid. Okay, now we can supply this liquid to this. So now we can supply this liquid to this. Okay, so how can you supply that? Okay, so here if I'm saying due to this expansion process, due to this work production process, we have lost some form of energy, right? That means here we can say the pressure at which the fluid has gone to this particular device, at this particular point the pressure has dropped. So pressure is one form of energy, you can say pressure energy. Okay, so at this particular phase it will be having high pressure energy, we can say, and at this particular region there will be low pressure energy. So now at this case also, what we have done, we have simply extracted the heat. We have not increased the pressure or decreased the pressure or decrease the temperature or increase the temperature. Okay, simply we have rejected heat, or we have rejected heat from the steam to the ambient at a constant temperature. Okay, and we know inside the vapor dome, so if I'm saying this is the vapor dome. Okay, and inside this, if I'm rejecting some amount of heat, let this is the condition. So let this is state point 1, this is state point 2. So it has been plotted between temperature versus entropy diagram, right? If I'm rejecting some amount of heat from here to here, in this case this is at constant pressure and this is also the case of constant temperature, right? So this is constant temperature and this is also constant pressure. That simply means during this process. Okay, so if I'm saying this is the state point 2 and this is the state point 3. Okay, so during this process there is no change in pressure and there is no change in temperature. And if I'm saying at this point pressure, at this point state point 1, if pressure is high, that means P1 is greater than P2. And if I'm saying this is the state point 4, at which our liquid water is entering to the boiler, so in that case also we can see P4 will be greater than P3. Okay, so in this case what we need to do, we have to increase the pressure of this particular liquid. So after increasing the pressure, we can supply this particular water to the boiler. So to do so, we'll be using a pump over here. Okay, so we'll be using another device whose name is pump. So this particular pump is used to increase the pressure of the liquid water and supply this high pressure liquid water to the boiler. Hope it is clear. So now this is how this our liquid water will be circulating over this cycle. Okay, so this liquid water, now again what will be, what it will be doing? So here our liquid water entered, right, and it has converted into steam. This steam has gone through this steam turbine, it has produced some work, and this steam has gone out of this particular steam turbine. Now it has gone to this condenser. Okay, so it has been condensed to the liquid water. Okay, after that it has been sent to the boiler by the help of the pump. Okay, so here again this liquid water, it is sent to the boiler. Okay, so this is the cyclic process by which we are getting work from the steam turbine. I hope it is clear. So what are the basic components in this case? In this case there are four most important components. What are they? This is the boiler. Let us try to write it down. Okay, so here you can see what are the basic components. As I have already told you that boiler. Okay, next one is your steam turbine, next one is your condenser, then next one is your pump. Okay, so here there is a beautiful diagram, or you can say the layout of your steam turbine. You can see. Okay, let me show you. Okay, so here you can see this is the boiler part, right? So this is the boiler. Okay, where we are saying that there is water. Okay, and there are some arrangements where your water is getting converted into vapor. Okay, so now after your liquid water has been converted into vapor, that will be sent to the turbine. Okay, so these are the blades you can see over here, right? So now when this steam will be go into the steam turbine, now it will be producing work. Okay, so it will be producing work. After producing work, okay, so let me use a pen over here. Okay, now here you can say we are getting some amount of work from here, and this work will be sending to the generator. So here we have given this particular work to this generator, and this generator will be producing electricity, and there is a transformer, and through the transmission lines the electricity will be distributed. Okay, so after producing work, the steam will be going to the condenser. So here this is the condenser. Okay, and in this case your after condensation your steam will be converted into the liquid water, and again it will be sent to the what, to the boiler. Okay, by the help of the pump. So here you can see this is the pump. Okay, now most important thing is that if we are heating the liquid water in the boiler, so where from we are getting the heat? So this is the furnace, you can say, right? So there will be coal which will be sent into the boiler, and there will be burn. So we'll be providing coal to the boiler, and inside this particular furnace we'll be burning it, right? So here we may burn. Okay, and this heat will be sent into the this particular boiler. Okay, so at this furnace we'll be burning this coal, and this heat which will be generated at the coal, that will be sent into the boiler. Okay, so this heat will be sent into the boiler. Okay, so when we are burning for that is coal, that means there will be some flue gases that will be going out through this. Okay, and here one case again, we are trying to condense the liquid water. That means we are trying to convert the vapor into liquid water. For that, what we are doing, we are taking the cold water from the river. Okay, so we are taking or giving to the your condenser, and this cold water, it is uh, taking the heat from the your steam. Okay, so if I'm saying, so let this is the pipe through which our hot fluid is moving. Okay, so in this case this is steam, right? So now what I will be doing, I will be circulating our cold fluid, right? So let this is the cold fluid which I am circulating over here, right? That means at this inlet I am providing liquid water, obviously liquid, and this is the cold, I can say, right? Cold liquid water, and this at this exit I'll be getting hot, right? So cold water will be sent through this particular pipe, and it is being circulated, right? So it is not mixed with this hot fluid, but this is circulated, and due to this it will be taking heat from this particular hot fluid. So this is how it is condensing the steam to the water, liquid water. So I hope all these how we are producing work, and what are the basic components of steam power plant. Okay, so these are clear. right? And if we be trying to learn what are the forms of energy our steam may be having with, that already we know, that is the enthalpy, right, plus kinetic energy v square by 2 plus potential energy gz1 gz, right? So this enthalpy, it is associated with the temperature. And if I'm saying we have added heat to this particular water and we have got maximum temperature, or maximum temperature, that is the superheated steam, right? We told that there will be getting superheated steam. That means we have converted the steam into a superheated steam. That means the temperature will be maximum in this case. That means we'll be having maximum enthalpy at this particular condition, right? And if we'll be increasing the velocity, then kinetic energy also will be maximum, right? So potential energy also maximum, we can say, right? So this pump of energy will be there with the flow, with the working fluid, right? Okay, so we may neglect this potential energy, but right now we are not going to discuss about this in detail. Still, you can have idea what are the forms of energy our steam will be having, right? So in some cases, we'll be neglecting this potential, this kinetic energy changes and potential energy changes during the work production. Okay, so that is the case when we'll be trying to solve any questions related to this one. In that case, we'll be learning about that, right? So now I think we understood how steam power plant works. Okay, for better understanding, let us try to see another layout where we can see the steam power plant and some more other components which are there. Okay, so I hope till now whatever we have understood, we have seen that the major components are what, that is your boiler, turbine, then your condenser, then your what, your pump, right? So these are the four important parts, right? So here we can see, so this is the cycle, right? So we are talking about this. So from this only we are getting work. Okay, so this part of the boiler should be producing steam, and that is sent to the turbine, and turbine is producing work, and this work is being feeding, it has been given to this electrical generator, and from this electrical generator we are getting the current, right? And this steam, it is sent to the condenser, and in this condenser we are cooling or the condensing the steam into liquid water. Okay, and how it is done, basically we are giving the cold water, and this cold water is getting heated, and again, so you must have seen this particular device, right? Okay, so this is the cooling tower. If there is no river, in that case we have to use this cooling tower, right? So how does this cooling tower works? So um, that is the out of scope for this particular course right now, so we are not going to discuss about it. But what is the function of it? Basically, if we are providing the hot water to the cooling tower, it will be cooling it, right? So at the outlet of this cooling tower will be getting cold water, and the inlet we can provide the hot water, so that you can remember, right? Okay, so there will be also a pump which will be through which this water will be circulated. So there is, you can say, there is one cycle over here, there is another cycle, we can say, right? That means from here we are getting the cold water. Okay, so from here we are getting the hot water, and this hot water is getting cooled, and this is sent to this particular device, that is condenser, through this particular pump. Okay, now, so after converting this vapor to the liquid, we are providing to the boiler through this particular pump again. Okay, so this is the cycle from which we are getting the power. Okay, so other than that, there are some other components, like in this boiler also we are having furnace. Okay, so that means where from fuel we are bringing and air we are bringing, definitely we are burning this fuel by the presence of your air, right? So how air will be sucked into this particular device, right? So that is another part of the discussion, but we are not going to discuss in detail of that. Okay, so in this case again, so let us try to understand something. That means here we are burning the fuel in presence of air, so that means here we, this flue gases will be moving out through this. Okay, so these flue gases will be going out to the ambient through this tank. okay, and this heat will be given to this particular what your steams, that is liquid. Okay, so I hope it is clear and you have understood how a steam power plant works. Okay, so keep studying. All the best for your preparation. Keep preparing yourself. Okay, so if try to understand it. If you will be facing any doubt, then of course you are free to ask. You can comment in the comment box. Okay, so I'll be happy to answer your every question. Okay, thank you for watching.